Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. Knowledge makes you great. APJ Abdul Kalam. Honorable dignitaries, guests, delegates, and all dear and near ones. A very warm good morning to all. It is my privilege to welcome you all to the 5-day online faculty development program on solar energy technologies and applications, organized by the Department of Mechanical Engineering, Jyoti Engineering College, Thrissur, sponsored by AICTE Training and Learning, ATAL Academy, New Delhi. And we are here for the inaugural ceremony of the faculty development program. Let us start the program by invoking the blessings of the omnipotent and the omnipresent, the creator of all wonders. We begin with a prayer.
കൈതൊഴാം ഞങ്ങൾ കൈതൊഴാം ഓരോ കണ്ണിലും വാഴും ദൈവമേ. കൈതൊഴാം ഞങ്ങൾ കൈതൊഴാം ഓരോ കാതിലും കേൾക്കും നാദമേ. നല്ല വാക്കുകൾ ചൊല്ലുവാനോരോ നാവിലും നീ വിളങ്ങണം. കൈതൊഴാം ഞങ്ങൾ കൈതൊഴാം ഓരോ കണ്ണിലും വാഴും ദൈവമേ. താങ്ക് യു.
A warm welcome expressed is ever cherished by hearts. I invite Dr. Deepan Raj B, Coordinator of the Faculty Development Program and Associate Professor, Department of Mechanical Engineering, Jyoti Engineering College, for the welcome address.
Honorable dignitaries, respected participants, and my dear colleagues, a warm good morning to one and all. It gives immense pleasure to welcome you all to the 5 days faculty development program on solar energy technologies and applications, organized by the Department of Mechanical Engineering, Jyoti Engineering College, and sponsored by AICT ATAL Academy, New Delhi. We are extremely fortunate to have the most eminent personality, Dr. K Srinivas Reddy, Professor, Department of Mechanical Engineering, IIT Madras, and also a honorary professor at University of Exeter, UK, as our chief guest today. On behalf of Jyoti Engineering College, I extend my heartiest welcome to you, sir. Next, in this auspicious occasion, I am delighted to welcome the most respected Reverend Father Roy Joseph Vadakan, Secretary and Campus Head, who is the backbone of our institute for many years. Welcome you, Father. I wholeheartedly take this opportunity with sincere gratitude to welcome respected Reverend Father Dr. Jose Kannambula, Academic Director of Jyoti Engineering College, in this occasion. Welcome you, Father. It's my privilege to welcome Dr. Biju PL, Head of Mechanical Engineering Department, Dr. Biju CV, Coordinator of this Faculty Development Program, and my dear fellow colleagues for this inaugural function. Foremost in this juncture, I would like to welcome all the resource persons and aspired participants from various institutions all over India for this program. Welcome you all. Thank you.
Thank you so much, Deepan sir. Reverend Father Roy Joseph Vadakan is a center pillar of our college and our constant supporter. He is a secretary and campus head of Jyoti Engineering College. With utmost happiness, I welcome Father Roy Joseph Vadakan for the presidential address.
Okay, dear respected Chief Guest of the Day, Dr. K Srinivas Reddy, Professor, Department of Mechanical Engineering, IIT Madras, Chennai. Our beloved Academic Director, Dr. Father Jose Kannambula. All the HODs, especially the Mechanical Head of the department, Dr. Biju Peel, and the coordinator, Dr. Deepan Raj, Dr. Biju CV, and all other dignitaries and all the faculty members. A very good morning to you all. And at the very outset, I wish you all the very best. I'm very happy today because we all are sitting in the online platform to think about ourselves and think about our nation. As we know, we the teachers, we the faculty members are the engineers of modern society. We are the backbone of the society, in other words. Why? Because we are the change agents of 21st century, especially the coming generation, the new generation. Therefore, if we are not ready to change ourselves, we cannot change others. There's a classical saying written by Jack Welch, one of the famous CEO of General Electrical Company. He used to say, the change outside is very rapid. It's very fast. If you are not changing yourself as per the fastness of the outside change, you will be dying. And I do believe that this is happening, especially in this pandemic scenario. The entire scenario and the world has changed. So we, the faculty members, are also supposed to change ourselves in order to equip with the 21st century needs. And I'm very happy that we are discussing a very important topic that is something connected to solar energy, the technologies and applications. As you know, solar energy is a God-given gift to us. The entire solar system, the entire system, ecosystem where we living are given by God. And how you are converting those resources into our own goodness as well as the goodness of society, definitely we are developing a better world. And we, all the education institutions, are supposed to create a better world and better ecosystem without utilizing much, but at the same time, without, consuming much, how we can compromise with those energies and those resources. So I do wish all the very best for all the discussions that is happening here and all the faculty members, those who are attending here. And I'm very happy that Jyoti Engineering College is becoming a part of this ATAL FDP program. As you know, since 2002, at the very inspection of Jyoti Engineering College, we have a clear vision, creating technology leaders of tomorrow. Then their Jyoti family stands for that. And our topic, the FDP topic, solar energy, the technologies and applications are very much close to this vision. So thank you, sir. Thank you, Srinivas, sir, for being here as a chief guest and all the dignitaries who are attending here, and wish you all the very best. Thank you. I remain.
Thank you, Father, for your valuable and inspiring words. We would definitely like to hear from the chief guest of the day. We are extremely happy to have with us Dr. K Srinivas Reddy as the chief guest. Dr. K Srinivas Reddy obtained his PhD from Indian Institute of Technology, Delhi, in Energy Studies in the year 1999 and joined as a teaching faculty at National Institute of Technology, Warangal. After a short service of about 4 years at NIT Warangal, he joined IIT Madras in April 2003 as an assistant professor. Presently, Dr. Reddy is a professor in Mechanical Engineering Department at IIT Madras, and he is also an honorary professor at University of Exeter, UK. He also served as an adjunct professor at CERI CSIR, Chennai, during 2014-17. I'm glad to welcome our chief guest for the inaugural address.
Good morning to all of you. At the outset, I thank the organizers for inviting me to give a talk on solar energy in the FDP program of solar energy and solar energy technologies and applications. I congratulate the organizers for organizing an important event on solar energy. And of course, it will be very useful for the younger generation at this point of time, because it may focus on various technologies. As you know that technologies are very important in the present day world, as well as especially for Indian conditions and for India also. So therefore, the solar energy technologies and applications are very important, especially uh, when we are when we need it for our sustainable solutions or sustainable applications. So therefore, this program is correctly chosen, and I congratulate the organizers for organizing this, and I hope you have got a good response. And in fact, I'm going to give a full talk after this inauguration. But what I mean to say is here is because you know that the importance of solar energy is very enormous, and as you know that the energy is one of the most important commodity that we are using every day. So after for any human survival, energy, water, air, and food are very important. But of course, some of these we get free of cost, but some we have to pay for them. But some of them we get freely, some of them we may not get freely, and some may have adverse effect on environment. So therefore, here it's very important to take care of the environment and energy. So the program is uh, chosen correctly at this point of time, and it will, especially in these pandemic times, it's very important to address the problem of energy through solar energy. So I wish the organizers all the best, and also I wish the college all the best for organizing such programs and disseminating the knowledge to the participants. Thank you so much.
Thank you, sir, for your enlightening words. I take this opportunity to welcome Reverend Dr. Jose Kannambura, man of great vision and mission, our academic director, for addressing the delegates.
Respected Chief Guest of the Day, Dr. K Srinivas Reddy, Professor, Department of Mechanical Engineering, IIT Madras, and also the Honorary Professor, Clean Technologies, University of Exeter, UK. Reverend Father Roy Joseph, President of the function. Coordinators, Dr. Deepan Raj and Dr. Biju. Head of the department, Dr. Biju PL. Various professors, dear participants from different part of the country. Already 159 have joined. I believe it will be coming closer to 160, 200. And my dear friends, I'm extremely happy to be part of this inaugural function of this AICT ATAL sponsored 5-day FTP on solar energy technologies and applications. First of all, I make use of this opportunity to express my gratitude primarily to the Chief Guest of the Day, Dr. K Srinivas Reddy, and then to the organizing group, that is the Mechanical Engineering Department of Jyoti Engineering College in Kerala. Its HOD, coordinators Dr. Deepan Raj and Dr. Biju CV, in a very great way, because they have taken the initiative. And also I want to make a mention of AICT for having granted this program to this college. And this is something very unique also. And this program is basically focused on solar energy technologies and applications. As all of us know, towards the end of the last century or the second half of this 20th century, people were running for new sources of energy. The conventional sources, basically fossil fuels, were getting depleted because they were overused. And secondarily, this was all damaging the environment in a very bad way. So people, scientists, engineers, national leaders, international people, all were concerned about this. And by the middle of last century, yes, people started to look for a new source of energy. And everybody found that sun is the source of all the energy, all forms of energy that is available on the earth. Maybe in conventional form, non-conventional form, maybe solar, maybe sea and waves, and so on and so forth. But source, if you look for, it is coming basically from sun. So if we can tap it directly from sun, then it is all the more good. Conversion may be comparatively easier than the other methodologies. And also the conventional sources of energy, the fossil fuels, they were damaging the entire scenario, the entire environment. So definitely we have to. And the advantage is that this is everlasting. As long as sun and earth, that solar system is existing, we will get this solar energy. The only thing is that we have to make use of unique technologies to tap it the best way with the maximum efficiency and effectiveness. However, this is focused on solar energy, its applications and technologies, even in the area of automobiles. So far, we all were depending on the fossil fuels. We were having diesel engines, petrol engines. Now, a total paradigm shift has taken place. People are running for electrical engines. And this electricity, how can we produce? Basically from solar. So this is the right time perhaps to go for this, and we have to convert the existing automobiles through our retrofitting and also to generate new automobiles with solar powered engines, solar powered motors or whatever we call it. So this is the right time and we are focusing on this. I believe these 5 days interactions, presentations, discussions, deliberations, everything will be focusing on this and definitely will create a big quantum of knowledge which can be getting disseminated into different parts of the country through the professionals who are attending it, through the students and the professors who are attending it, so that a better tomorrow can be created, making use of the solar power. Let it happen. Let us all network together, work together towards a big goal of achieving this. And finally, a day must come that India must be standing first on the top of the world in this area of tapping the solar energy, making use of it for the real actual activities of the day, right from the beginning to the end, so that we will be a safer country, we will be a safer environment, making use of this solar energy. And our dependency on the unconventional sources of energy, namely the fossil fuels, may be coming down and down, because once it is completely utilized, depleted, no more we can replace it. Moreover, they are doing the damage, whereas the solar energy can be used for long. So let it happen with all our interactions, deliberations, and activities and networking and scientific research and further activities connected to that. Let it happen. I wish you all the best for a wonderful program on this 5-day FDP on solar energy, technologies and applications. Wishing you once again, thank you very much.
Thank you, Father, for your energizing words. Gratitude unlocks the fullness of life. It turns what we have into enough and more. I now invite Dr. Biju CV, Coordinator of FDP and Associate Professor, Department of Mechanical Engineering, for delivering the vote of thanks.
A very good morning to one and all. It's an honor and privilege for me to thank each one of you attended the inaugural function of the online FDP on solar energy, technologies and applications organized by Mechanical Engineering Department of Jyoti Engineering College, Cherudiri. As you know, the program is organized with the financial support of AICTE, the Training and Learning ATAL Academy. The encouragement and support received from the authorities right from the beginning is really commendable. On behalf of the organizing committee and Jyoti Engineering College, I would like to thank AICTE authorities present in the inaugural function. Today, the inaugural program is presided by Reverend Father Roy Joseph Vadakan, Secretary and Campus Head of Jyoti Engineering College. The great visionary and brilliant academician, both in the fields of engineering and management, is the backbone of this FDP. On behalf of all the people participating in the program, I would like to thank Reverend Father Roy Joseph Vadakan. Thank you, Father. We are extremely lucky to have the eminent Professor Dr. K Srinivas Reddy, faculty in the Mechanical Engineering Department at IIT Madras, and honorary professor in Clean Technologies, University of Exeter, UK, as the chief guest of the inaugural function. I sincerely thank Professor Srinivas Reddy for accepting our invitation and as the resource person for the first session of this FDP. Thank you, sir. Our academic director, Reverend Dr. Jose Kannampuzha, who has vast experience in the engineering education, shared the importance of FDP in his special address. His enthusiasm and vision to improve quality of teaching learning methodology has got wide acceptance from technical community. I take this opportunity to thank Reverend Dr. Jose Kannampuzha for his valuable presence and message delivered in the inaugural function. Thank you, Father. Dr. Deeban Raj B, coordinator of this FDP and expert in the area of energy management, has taken a lot of pain and effort to make this program into a reality. His hard work to identify the apt resource person for each and every session will definitely make this program a unique experience. I sincerely thank Dr. Deeban Raj B, coordinator of ATAL FDP. Thank you, sir. I acknowledge the unwavering support received from the head of the department, Dr. Biju PL, convener of FDP, and the faculty and staff members of the host institution. Once again, I thank everyone who made this inauguration of ATAL FDP a successful event. Thank you.
Thank you, Biju sir. Thus, we have come to the end of the inaugural session. Thank you, sirs and madams, for your esteemed presence. We are about to begin the first session of FDP, and it's my pleasure to welcome Dr. K Srinivas Reddy for handling the first session. Dr. K Srinivas Reddy obtained his PhD from Indian Institute of Technology, Delhi in Energy Studies in the year 1999 and joined as a teaching faculty at National Institute of Technology, Warangal. After a short service of about 4 years at NIT Warangal, he joined IIT Madras in April 2003 as an assistant professor. Presently, Dr. Reddy is a professor in Mechanical Engineering Department at IIT Madras, and he is also an honorary professor at University of Exeter, UK. Professor Reddy is a fellow of the National Academy of Engineering, and he is specialized in renewable energy with special research interest on concentrating solar power, energy efficiency, and environment. He has 8 patent applications and more than 252 publications, of which 136 papers in reputed international journals, including 5 review articles on solar energy systems and energy storage. He co-authored book on sustainable energy and the environment, a clean technology approach, published by Springer, and book chapters on solar energy systems are popular among energy and environment community. Professor Reddy is actively involved in the implementation of solar thermal technologies for power generation and process heat application through design, development, demonstration, deployment 4D approach. He has executed several research projects related to solar energy and environment funded by various national and international agencies such as DST, AICTE, RCUK, etc. In recognition of his research work, Dr. Reddy received several awards such as WSSET Innovation Award, Sri J.C. Bose Patent Award, and twice the Bhagyalakshmi and Krishna Iyengar Award. He also won Career Award for Young Teachers from AICTE in 2003. Very recently, he received the Mid-Career Level Institute Research and Development Award. He is an expert committee member in various selection review committees and the visitors nominee for IIT Delhi. As a part of human resource development activities, he supervised over 176 UG, PG, and PhD students. Most of them are well placed and working now in prestigious organizations. He organized several national and international workshops on advanced renewable energy technologies. It is my pleasure and privilege to welcome Dr. K Srinivas Reddy for handling the first session.
Can you see it? Hello?
Yes, sir.
You can see the screen. Thank you so much. Thank you for giving nice introduction to the participants. So I will start my talk. The talk is on solar thermal energy utilization, technologies and applications. As you know that we are facing several problems, and of course the top 10 problems, if you list out for next couple of decades, the energy is one, water, food, environment, poverty, terrorism and war, diseases, education, democracy, population. So these are very important problems now we are facing, and of course in different stages. The top most problem which I have listed out here is energy. And energy, when you try to address the problem of energy, because the energy is very important for human beings and also livelihood. So therefore, the energy is extensively used nowadays for our needs. But when we start using energy, obviously the required energy need to be supplied. But the problem is there are several other issues. But when we try to address the problem of energy, then the energy cannot be addressed alone in isolation. So therefore, energy and environment, they go together. When we address the problem of energy, we have to address the problem of environment as well. So therefore, the energy environment interaction is very important in present scenario. So the energy can solve most of these problems. The energy consumption is rapidly increasing across the world, and it is growing rapidly. And of course, in some areas, it's deprived of energy, and so in some other areas, excess use of energy in an unsustainable way. But generally, the energy consumption is an indicator which shows the standard of living of an individual or a country. So therefore, the energy consumption is a very important role in any country's development. So if you consider the energy usage, what we call energy system hierarchy, there are energy sources, then energy carriers, and of course translating into equipment and services where we can comfortably use it. So the energy sources are primarily based on fossil fuels, larger extent, and nuclear and renewables. This fossil fuel includes coal, oil, gas, and renewables also plays a major role nowadays, and they are gaining momentum, and they can be conveniently transformed into energy carriers. They can be either liquid fuels or electricity, or utility scale application, combustion of feedstocks. So they can be converted into either mobility applications or users buildings, mainly space conditioning or built environments, or of course any consumer choice. So this is a typical energy system hierarchy. And if you look at the energy services and sources through over the time period, and of course the commercial use of energy sources started industrialization started. It's about 1870s. Before that, it was mainly animal power, say exploitation of animal power or human power, or any local powers. But even if it was animal power or local power, it can be the source for energies always be the sunlight. So therefore, the sunlight is transformed into feedstock through photosynthesis, and then it is used there. But subsequently, the industrialization started, and once the industrialization started, the commercial fuels started exploiting or using them for applications, exploited or using for the applications, and the coal, gas, and oil played a major role as the time proceeds. And of course, so these days the fossil fuels have been exploited indiscriminately for our use. So that resulted in environmental damage. Therefore, one should take care of both energy and environment in a judicious way. But if you look at these timelines, all the fuels which are used, mainly hydrocarbons, and in hydrocarbons, the content of hydrogen plays a major role. See, as we improve the end-use efficiency of the fuel, obviously the hydrogen content has to be higher. So in future, if we not only look at the present scenario, if at all we dependent on some fuel, comfortable fuel, that has to be hydrogen-rich fuel. So therefore, the future will be the hydrogen fuel. So what I mean to say here is maybe if you consider from 50 years from now, the hydrogen will have a major role, mainly to supplement or complement the energy scenario. So the hydrogen is a fuel, but it has to be produced from some feedstocks with some energy. But obviously, if you use fossil fuels, it will reflect again into the environmental problems. So therefore, it's better to use the renewables for producing hydrogen. So therefore, there are various methods by which one can produce the hydrogen. I have mentioned here natural gas, biomass, sunlight, wind, and uranium, any one of those. Either you can go for electrolysis or steam methane reformation, any one of those. But what I mean to say is the future would be the hydrogen economy for various applications or supplementing the energy source. If you look at the Earth in the night, it looks like this. The energy demand and prosperity is very important. Wherever it's highly illuminated, the location which is, this is the photograph which is taken night time. So wherever it is illuminated, highly illuminated, that means there is energy demand, and of course their energy rich, or their standard of living is very high, or their prosperity is high. So there are some locations where we have uniformly illuminated or uniformly non-illuminated. And of course, if you look at the the contrast picture of this is the what we call it as energy demand, and the contrast picture is the energy poverty. And you can see that there are several countries missing here. And this map shows that how the world is under energy poverty. So there are several countries are under energy poverty. They are deprived of the energy sources in a proper way. So if you look at this area, it's a SAARC countries. Several millions of people do not have access to the electricity, and several million people they are still using the biomass as the primary energy source, because you know that for human survival, as I mentioned earlier, air, water, and food are very important. Somehow air we are getting free of cost, though it's not very clean. It's a polluted air, but still we are getting free of cost. But the water, next is the water, but the water we are paying for that. So maybe if you look at a couple of decades back, the water used to be free and it's available free of cost. But unfortunately, because of the indiscriminate usage of fossil fuel sources and the resulted pollution, caused most of these water bodies highly unusable. So therefore, we are paying for the water. But the next one is food. Food is very important, but we cannot eat food in a natural form. The food needs to be processed in a proper way. The basic food processing that we use every day is cooking, because we cannot eat raw food. So therefore, cooking is one of the important food processing. So for that, it requires energy. That energy what we are using is firewood or biomass. So therefore, there are still several millions of people are dependent on biomass. And you know that the effect of biomass, we are cutting the trees, obviously it will become environmental problems. So not only that, the cooking process is also not hygienic, and which may result in all healthy all health related issues and problems. And you see that there are some countries are missing from here. And if you see, about 1.6 billion people have no access to electricity, and 80% of them are in South Asia and Sub-Saharan Africa. So therefore, the energy problem is very important now. There is if you look at how do we solve this, there is a changing global energy scene, and this is because of various factors. One is the high energy prices, then security of source concerns, and growing energy demand. Climate change is another problem, geopolitics, and of course resource nationalism. All these are major factors which influence the changing global energy scene. So therefore, this energy scene is driven by, there is a close energy goals and drivers. The energy goals are accessibility, availability, and acceptability of the energy source. And these goals are driven by drivers, mainly GDP, energy demand, and energy supply. And they are very closely linked dynamically with the demography, environment, institutions, prices, technologies. So therefore, this 3A, what I coin it as a 3A, accessibility, availability, and acceptability, or plays a major role. But these 3 A's are expanded into 6 A's, and those 6 A's include accessibility, affordability, acceptability, adaptability, appropriateness, and assurability of energy source or energy supply. Of course, now if you look at the global energy outlook is primarily dependent on fossil fuels, coal, oil, gas, and of some extent nuclear. But now the renewable energies are gaining momentum. If you look at the present energy, based on present energy scenario, based on the present fossil fuel consumption, there's if you take, for example, the oil is extensively used for mobility and in automobiles and other sectors. So the oil sources are depleting day by day, and we have only reserve to production ratio of 42. If you look at here, about 40 to 45 years now, and these resources are unevenly distributed across the world. In some area you have a large amount of resources, some area we have less, and especially in India, the oil reserves are very, very minimal, and we are importing large extent of oil from other countries. And these oil reserves can be exploited with the technology. Technology plays a major role. This workshop is on energy, solar energy technologies and applications. So therefore, even if the resource is available, if you want to convert them into reserve, we need to use the technology. And this figure shows that the technologies which are used for oil exploration and oil exploitation, these are the sizes of the drill. So the present technology, which can even go up to 1.7 kilometers deeper, and even the resources are even further deeper, we can exploit them in an economical way. But even if the resources are available beyond that, it's of course the present technology can drill even up to 30 kilometers or so, but it may not be, the resource may not be viable when we go for deeper and deeper. But then the technology plays a major role here. So you know that oil is one of the important energy source for now, and you know that the automobile sector is also growing. Most of us are mechanical engineers, you know very well. If you look at Indian automobile sector is rapidly increasing, and if you look at maybe 2 to 3 decades back, we used to have only a couple of car companies. Now, if you name any company in the world that is there in India, we can buy an automobile, a car, when we have money, when we can afford it. So we can, but of course, most of these technologies are not Indian technologies, and we import technology, and of course we manufacture here, and we feel we deserve for a nice car like this. And why we deserve? Because we need, we can afford it, we can buy this technology. But what happens is, if you buy this technology and use it on an Indian roads, you need fuel. But most, as I mentioned just now, that the fuel is completely larger extent, more than about 60 to 70% oil is imported, and that will result in huge foreign exchange transfer. So what happens is, the not only affordability but also reliability is a major important issue, because the supply of fuel is very important. And if there is any unrest which may result in short supply of fuel, obviously, because we are largely dependent on imports of the fuel, so this car may land up into this, though we deserve for that, but if you don't have fuel, indigenous fuel, we may land up into this condition. So therefore, sustainable energy supply is very important. The energy sustainability is very important. So if you look at the Earth globe, it looks like this in bluish color, but it's surrounded by the environment. You know that the atmosphere is about 15 kilometers thickness, and it's surrounded by this. And if we indiscriminately use the fossil fuels on this Earth, and it completely imbalances the layer, atmospheric layer, and it's getting polluted day by day. So therefore, indiscriminate use of fossil fuels, we are literally burning of the Earth's atmosphere. And any overloaded, why we are polluting this, because of fossil fuel energy usage. When we use excessive fossil fuels, what happens is the atmosphere will become imbalanced. That means we are emitting large amount of undesirable gases into the environment. That means we are overloading the atmospheric system. Any overloading, any overloaded system looks like this. If you overload, it will become completely imbalanced. So therefore, sustainability is very important. Resource sustainability is very important, and mainly energy sustainability is very important. So if you have resources like this, you can consume whenever you need it, and because there is no much effort to use them, there is no technology involved. So therefore, what happens is, if we start consuming like this, over a period of time, this will become empty. That means these fossil fuels will get exhausted or extinct. So therefore, what happens is the future generation may not have any resources left. So therefore, it is very important to develop a technology and keep these resources for the future generation. And these resources can be kept for a future generation, and one can use their own share like this by developing this technology. This technology, you have seen this difference. This technology, as far as the energy sources are concerned, renewable energy technology. You develop a renewable energy technology and keep these resources for the future generation. So by general definition of sustainable development is the development that meets the needs of the present without compromising the ability of future generation to meet their own needs. That means one should or one should use their own share rather than the other's share, and you take your own share or you use your own share, but keeping the other share intact and in a sustainable manner. So therefore, it's very important is energy sustainability. That's why the future generation says that there is only one earth, we have to take care of it, please. So therefore, energy sustainability can be attained by developing appropriate technologies, as this workshop or the FDP program is on mainly technologies and applications. So therefore, I strongly advocate development of indigenous technologies for local people or Indian conditions. So therefore, developing indigenous technology based on renewable energy technologies are an important solutions for the present energy demand. So therefore, it's your money, your environment, it's your mission to mission readiness. So therefore, it's we have to conserve this nice bluish earth. So therefore, the best way of conserving the earth is developing renewable energy technologies. So as a part of this activity, renewables means mainly solar, because solar is the only major source of renewable energy, and all other forms of renewable energy like wind, biomass, and ocean and other forms of energy sources are manifestation of solar energy. So therefore, so generally, though we classify renewables into different way, but the renewable means only solar. So using this solar energy, you can cater the present needs, or one can cater the present needs. As I mentioned, that the technology development plays a major role in present conditions. So therefore, as a part of our activities, we have developed various technologies at IIT Madras, and these includes, I have listed out about 20 technologies. Now it's more than my group is actively involved in development of indigenous technology through 4D approach: design, development, demonstration, and deployment. And you first design the technology, and then you develop it to the higher level in order to improve the performance and reliability, and of course cost constraints also. Then you demonstrate at a deployable scale. Then you take it to the field and deploy it. And of course, we are closely associated with various industries. They can take care of the next part of commercialization. So therefore, the 4DC, and there is a prefix R also. We do research and 4Ds and then C. 4D R, 4DC: research, design, development, demonstration, deployment, and commercialization. So as a part of that, we have developed these 20 to 25 technologies, but I have listed out here 20 which are related to the solar energy. I'm not going to read out this, but anyhow, I'll explain one by one how these technologies are very important. Solar energy technologies are very important, how they are used for applications, because this FDP is on solar energy technologies and applications. So I will show the technologies as well as some applications. So this is my lab, and these are my students, and this is solar energy research facility, and we have various solar energy developments, and that I'll show here. This is another view of solar energy research facility. We have mainly solar energy technologies, which covers both photovoltaics and solar thermal. And but today I will more focus on solar thermal. Solar thermal is they are the technologies which convert the solar energy into into heat or thermal energy, and subsequently this thermal energy can be used for various applications. So this is another view of my lab, and this is a dish, parabolic dish, which is a 2-axis tracking system which it's in parabolic shape, 3D parabola, and it focuses radiation, solar radiation onto the this receiver here, and this receiver is a boiler which converts solar energy into heat, and maybe in the form of superheated steam or any hot working fluid. So this is as I mentioned that our approach is 4D approach, so therefore it's a demonstration scale, and this is about 20 square meters, and it gives about 50 kilowatts thermal and 15 kilowatts thermal at 640 degrees Celsius. It's 67% efficiency. We have a photovoltaic system with tracking, which is about one kilowatt system. The conversion efficiency is about 16%. Then we are working another application of solar energy is the desalination. Water is very important now, so therefore producing potable water from the sea water or brackish water is very important for the present needs. So therefore we are also working on solar desalination is an important application. And this is a single axis parabolic collector, which we call linear parabolic trough, linear parabolic collector at trough. And then we are also working on concentrating photovoltaics here. And this is also parabolic trough based concentrating photovoltaics, in which it's a both electricity and heat are produced. And this is almost 1/3 is electricity, the 2/3 is the heat. Then of course there is a lot of radiation measurement devices and all. And if you look at another view of these from backside view, and as I mentioned, that is our approach is a 4D approach. So therefore in the lab itself we develop at a demonstration level so that they can be easily deployable, because now Indian industry, they want a final solution. They don't want a lab or a test tube type of solutions. It has to be demonstration solution, so therefore they can easily take it to the field. So that's why with respect to these people who are standing, they are much bigger systems in the lab itself. This is in our lab. And you can see the another parabolic dish, trough, and this is the desalination. This is all integrated collector storage system, evacuated systems, and so on. And we have also commercialized some of our industrial collaborators. They have taken to the field, and this is one of them where it's located in Hyderabad. They placed it in a pharmaceutical company, and the solar energy is supplied to the pharmaceutical company. This is another company which is located in Chennai. They are using these collector systems for process heat applications. And of course, as I mentioned, that the hydrogen is going to be the future fuel. So therefore, hydrogen energy conversion through through renewable energy is very important. That to solar energy. So therefore, this is the system which converts solar energy into hydrogen by decomposing the feedstocks like methane or water or ammonia. Any one of those can be used. Here in this case, methane is used. See, methane is again produced from biomass. So therefore, it's a complete renewable energy cycle. And this I have already shown you this because this is a closure view of the process heat plant in Hyderabad. And this is about 85 square meters, and it produces about 20 kilowatt electric or 66 kilowatts of thermal energy, which is used for pharmaceutical company. You can see that this is this technology converts solar energy into superheated steam. In this, you can see that the entire radiation is focused onto this receiver, and this receiver converts the solar flux into heat and subsequently supplied to the working fluid, and working fluid gets heated up and then comes as a either if it is a water, it's a superheated steam, and if it is a or thermic fluid, it will be a hot fluid. And this is another technology we have developed for both power generation, electrical energy generation, as well as process heat applications. The smaller one is This is a parabolic trough collector. It's a mini power plant. You can see all these balance of plant and the heat exchangers and then energy storage systems and so on. So this is for flat plate. This is for process heat application. This is a power generation application, and all these are located on the fourth floor of our lab, one of the labs. So you can see that there can be roof mount. We have given enough support structure in order to take care of the structural stability. You can see this. And we have also installed another concentrating plant in a school which is close to Chennai. We from 70 kilometers away from Chennai. It's in Kanchipuram district. It's called Vallipuram, and it's located at the school which is called the Pathshala campus. This is a J. Krishnamurthy Foundation school, and this produces electricity, hot, heat, and cold. This is a tri-generation system which produces electricity, heat. Heat means this heat is used for cooking application and hot water applications, and also produces cold, that is air conditioning for the campus residents. And this produces about a heat 50 kilowatt thermal, but now it's a 500 kilowatt system, and at 5 bar and 350 to 400 degrees Celsius. And we are actively involved in the simulation of these new technologies, mainly for various applications, thermal applications. Here, this is the two-phase setup. It's indoor. First, we do indoor testing, and then we will take to the outdoor and field application. This is one more large-scale application by the Coimbatore-based company, and this produces high-pressure, high-temperature steam. And these are the solar collectors. They focus onto this receiver here, and it is you see that it goes like this and comes back here, and you can see down here it's a superheated steam. And the steam is shown here, how it is coming. This steam can be used to drive the turbine. This steam is expanded in a turbine. In turn, it produces motive power. So you can see with respect to the surrounding buildings how big it is. And you have seen my another lab, which is based on solar dish. This is the fifth generation collectors. So we call it the 5G, the solar collectors, and they are used for air conditioning. This is the air conditioning at the back side of this. It's a thermal air conditioning, and this you can see process heat activities. And there is a boiler which is located mounted here. This can also be used for concentrating photovoltaics. And the reflected radiation, the radiation is reflected and focused onto this boiler. And in this boiler, the concentrated heat flux is converted into heat, and heat is subsequently transferred to the working fluid. This is a working principle, and working principle can be a superheated steam. As I earlier mentioned, it's a hot working fluid, and these are various storage tanks and so on. And you can also use this system for producing hot water, mainly a domestic hot water system. We have developed a new type of solar hot water system, which we call integrated collector storage technology. And this is in this, the collection and storage is in the same unit, so that the cost of the solar hot water system reduces substantially, because it's compact and it's integrated both collection and storage in the same unit. And there is a material which can be placed over this, and then which can reduce the heat losses substantially. If you look at this cross section, it looks like this. The tank cross section is this. You have a hot water system, then covered with transparent insulation material, and the sides and bottom is covered with thermal insulation. The another one technology is the photovoltaic, and this photovoltaic converts solar energy into electricity. But what happens is their efficiencies are rather low. So therefore, in order to improve the efficiency, we need to track this. We have to keep always the panel in the direction of the sun. So therefore, it needs to be tracked. So that tracking can be done by this single axis semi dual axis tracking system, and it's a very cost effective, and it's very comparatively it produces more energy than the normal PV panels. We'll get additional energy without much cost in the tracking system. So this one of my undergraduate students has developed this tracking system. It's a very simple system, and this gentleman actually. So then you have concentrating photovoltaics. Is a parabolic trough based concentrating photovoltaics. This solar energy concentrates onto this receiver, where these photovoltaic cells are placed here, and these photovoltaic cells are heated up. So therefore we need to cool it by a working fluid. Say this is the working fluid circulation tank, and the solar cell is unlike the normal silicon cell. It's a triple junction solar cell, and with a different graded junctions. So therefore it converts solar energy very efficient way. It's almost for 40%. And in contrast to the reflecting type, we can also have a refracting type or lens based solar systems. They convert solar energy into a hot flux, that is a spot, and in this spot if you put the PV system or photovoltaic, this triple junction photovoltaics here, and it converts very effectively. So you need to have a thermal management system, need to cool the cell. That is done by this fins which are located. This is the heat sink fin, and there is a secondary concentrator which will be placed somewhere here. And another one is, because you see most of these solar systems have to be tracked in order to have a better efficiency. This tracking means we are tracking the sun. So the movement of the solar collector along with the sun, then that will result in higher cost, because we have to have a tracking system, motors and control systems. So but what happens is, if we don't want high temperature heat, maybe if we need a moderate temperature heat, we can get away from the implementation of a tracking system. So therefore we have to go for a non-tracking system, but still we get a reasonable high temperatures heat. So therefore, as a part of that, we developed this a new type of hyperbolic elliptical concentrating system. This elliptical is the aperture like this. It looks, top view is this, and side views are hyperbolic, and the solar radiation is concentrated for a larger acceptance angle, and then it produces appropriate heat. So this is the heat flux conditions, and it looks like this. This is the elliptical aperture, and it's coated with reflective mirrors, and then it focuses onto the bottom surface here, like this here in this, and then we need to recover this heat by a heat exchanger here, and it looks the focus looks like this here, and in order to take care of this focus, you need to develop a sinusoidal kind of cavity receivers, and the performance is better. We can use it for various applications, mainly desalination. This is a solar desalination system which is used for converting seawater into potable water, or brackish water into potable water, or sometimes wastewater treatment also. This can also be used for wastewater treatment. Mainly, you know that the wastewater is also polluting the environment, and most preferably in water bodies and all these. You see, most of the water bodies in India are polluted, and it's very difficult to use the water from water bodies. So therefore, it's very important to either treat the effluents, either domestic or industrial effluents, or the brackish water into potable water, conversion of brackish water into potable water. As a part of that, we developed this, and it uses latent heat, and it's very efficient as compared to conventional desalination systems, because the most important aspect is waste heat recovery here. So it involves the cross section of this is like this. You have different stages, and solar energy is supplied to this, and the evaporation condensation happens here. The condenser and evaporators are in this, and they are sloped towards other side. So therefore the collection is the plate acts both condensating and evaporating surface. And based on this, we found that the 4 stages are good, and it can be yield is about 15 to 25 liters per meter square of area in a day, and with a reasonably good efficiency of 40 to 60%. It can handle any type of water like fresh water, brackish water, saline water, brine, mainly any type of water. And another technology which is used for water production is this vertical type of still, and either sides, both the sides are used to absorb the solar energy, and it's a very cost-effective system, and the performance characteristics are very good, and yield with observer temperature throughout the year, and is very good. So therefore, this is a good option for rural applications or portable applications. And another still is based on the multi-steps. Is a new technology where you can keep the brackish water into different trays, so that the effective area of the exposed area is substantially improved. So therefore, you can see these performance characteristics, mainly yield and energy and exergy efficiencies of these. The performance can be improved by adding some wicks into this. So therefore, the overall system performance is higher for water production. And another important technology, because nowadays it's very important that the wastewater need to be treated properly, and also another thing is the hygiene is very important, and the present problem is mainly sanitation. The sanitation may be in terms of this, appropriate implementation of toilets and so on. So therefore, as a part of that, maybe Swachh Bharat, under Swachh Bharat conditions. So we have developed a zero discharge toilet powered by solar energy. So the zero discharge means there is no liquid, neither liquid discharge nor solid discharge. So everything will be consumed inside and then used for energy applications. And as a part of that, we have come up with a solar dryer for human waste, into converting human waste into fertilizer. This is a synthetic waste which during the experiment we have done it and then used for development of a zero discharge toilet, which I am going to show. We have also installed this complete technology in one of our students' hostel. This is, as I mentioned, that treatment of effluents, mainly that in India we have large textile hubs, mainly in Tamil Nadu we have Tirupur hub and all, and most of these textiles are rejecting the effluents into the atmosphere, and some are treated, some are untreated. So therefore, it's very important to come up with a solution for treatment of these textile effluents. So as a part of that, we have installed one solar-driven textile effluent treatment technology developed here. This is located in Tirupur, and it's based on solar energy applications. So the solar energy is used to treat the effluents, and we have come up with some characteristics how this performance can be improved. This is installed in one of the textile industries in Tirupur. These are my colleagues from chemical and civil engineering. We are as a collaboratively given the solution for textile industry because it involves environmental issues also. And again, as I mentioned that for human survival, air, water, food, and energy are important. Apart from this energy, you have another important thing is shelter. Shelter is very important. Then built environment is very important. So therefore, again, nowadays the present built environments consume a lot of energy, and they're highly energy intensive environments. So therefore, in order to solve the problem of built environment energy energy supply, or we have come up with a net zero energy buildings. This is a conceptual picture. It covers with the solar panels and then wind energies, and of course it's a completely zero discharge, means these biomass which is produced out of liquid and solid discharges can also be treated and used for other applications or energy applications. So the another view of this is this: the panels can be moved up and down, and it's integrated with the building, and it's a portable building. We have developed as a 1 BHK as a prototype in IIT Madras. This is under Indo-Canadian project, and you can see that there is a proper ventilation with this, and it's completely net zero energy building in terms of materials, in terms of the architecture, in terms of energy use, and in terms of waste generation and mitigation. All these, it covers all aspects of the built environment requirements. As I mentioned earlier, that we have developed a toilet, net zero toilet, zero discharge toilet, which is no solid, no liquid discharge. Solid liquid discharge is taken up, and you see that this is a solar panel which drives the motors of this, and this there are 2 toilets installed in Krishna hostel. So the liquid and solids are separated, and then liquid and solids are treated here, and then the liquids are recirculated back, and some makeup water is added. But whereas solid becomes a powder, and the powder can be burnt inside to give the heat, or can be used as a fertilizer. So ultimately it is a net zero discharge, and we have given this technology to one of the companies based on Mumbai. So they are commercializing this technology. We have licensed to them. Then another thing is integrated renewable energy system is very important. So when we mainly rural areas, we don't have enough reliable power supply. So therefore it's better to develop an integrated renewable energy system to cater the needs of the village requirements. And mainly we have installed this biomass solar energy based system in a tribal village close to Shantiniketan, that is Vishwabharati University, Rabindranath Tagore's place in West Bengal. And this system is placed there, and it produces biogas, and the biogas is used to drive this generator set, and then it produces electricity during night time, whereas daytime you can still use solar panels here, and if excess energy is there, it can be stored in storage here, like that. It's an completely integrated renewable energy system in a standalone mode operations. So the complete system development has been done, and it's installed in one of the tribal village, which they do not, where they do not have electricity. Of course, this not only produces electricity, but also produces cooking gas, and also potable water. And it operates in an integrated way. So we have developed complete control system, then biogas operation, and converting biogas into how to inject into the IC engines with the appropriate injection system, as well as the spark ignition and other, because here the biomass is a different ball game as compared to the gasoline condition. So therefore the engine has been modified in order to take care of the biogas. And this is the control system, which you can not only when you have a grid can also be connected, PV, biomass, grid, and then it caters the in a standalone mode to the rural applications. So you can see, but I'm not going into details because and another thing is, as we discussed that earlier, the automobile sector is rapidly increasing. Most of the, if you take consider the cars which are available on the roads in India, most except 1 or 2 cars, or most of the cars are foreign cars only, foreign technology only. And of course we use foreign technology and foreign fuel and pollute Indian environment. So therefore it's important to develop the electric mobility. So we, as a part of our activities, we have developed an electric auto rickshaw based on the solar energy. Solar panels are integrated with the auto rickshaw, and then it's run, and its complete development has been done with these are the specifications of that, and you can see these different motors and all these the control system, how it works, and we have done complete structural analysis and operated under different load conditions. If because Indian road conditions are different, Indian loading conditions are also different. So therefore, as per Indian loading and Indian road conditions, the control systems developed and structural stability is also considered. You can see that these are the various components of this. When it's assembled, it looks like this, and these are the specifications of this: the motor, battery, and charger, driver, and axles, and so on. So what is the grade ratio, and accordingly the appropriate control system need to be implemented. So, but you know that in real condition is different, because you have wind drags, loads, both the dynamic and static loads. In order to take care of that, there should be minimum dynamic loads. So in order to take care of both static and dynamic loads, and evolving the structural components according to the load conditions, we have done complete and comprehensive structural analysis. These are some of those specifications with the different parameters, how almost it can work about 30 kilometers per hour of wind, head-on wind, which is in the opposite direction. So, but it's very important to compare with local technologies, how we compare this. You can see that this auto rickshaw, which a comparative study has been carried out with appropriate cost comparison, as well as the CO2 emissions, environmental issues. So therefore, the overall techno-economic and environmental analysis gives us that the EV based on this may give a better solution at timing. But of course, this technology need to be implemented in a mass scale for catering the local needs. So these are our students. When they were testing for different load conditions, they were doing this. And again, as I mentioned, that the comparison has been done, and it's found that about the payback period of 4.5 years, we can recover most of this, and ultimately it's a viable technology, solar energy based mobility system. So therefore it can be even implemented in a large scale in order to maybe hopefully soon this will become a practical reality. So this is this system is very good because there are several advantages: zero greenhouse gas emissions, reduction in energy cost, less noisy as compared to the IC engines, and of course, when we are using solar energy, it's an unlimited source of energy. And with this, I conclude. I think we have just another 5 to 10 minutes for interaction. So our solar energy technologies are based on R4DC approach. So therefore, this is my group, and with this, I have given some solar energy technologies, the development of indigenous solar technologies, and their applications for various utilities. So therefore, there is a great potential for solar energy, especially in India, because India we have about 300 days of sunshine. So therefore, we have abundant sources of energy, mainly usable form. So therefore, our energy requirements can be met by solar energy in more sustainable way, so that the overall sustainability may be attained with a less or minimal impact on environment. So these are my group, and I thank for patient listening. And as you know that the organizers have given great introduction of mine. So there I am again. I'll give you in brief what I am and where from. So you know that I am from IIT Madras, and I hope most of you have seen IIT Madras. If you have not seen it, it's a close to 600 to 700 acres campus. It's a reserve forest, and we are living in a reserve forest with our friends like this. There are 500, more than 500 deers with 5 varieties, and then we have snakes, monkeys, and of course all types of animals. We are living with them, of course. So therefore, now if you look at this friend, she's looking at you seriously. This friend is looking at seriously for what? For questions. See, if you have any questions, please ask this person. I will answer on her behalf. Thank you so much.
Participants can ask their questions.
If you have any questions, please either you can put it in chat box or you can ask it. No problem. If at all you have some. Okay, if there are no questions, then I thank the participants and the organizers for patient listening to me. There are some questions, it seems. How auto rickshaw work on rainy season? Because this is also hybrid system. So battery is also there, because the solar panels powers the battery. So therefore, if during rainy season we can use a conventional electricity for charging the battery. So therefore, it can still work under rainy condition also. Water treatment system deposits. What about deposits? The deposits means mainly what happens is, you know that if you talk about seawater desalination, if you take some fraction of water, maybe 5 to 10% of the water, and the rest is brine, but less concentrated in brine, that can be rejected into the environment. But in case if it is if you want to recover large amount of water, then it will become a salt production. So this salt deposition or brine is it's a trade-off. Whether sometimes this desalination system can be used for both water production as well as salt production. Sometimes is a combined. That depends on how you discharge the brine into the environment and how you handle the brine effectively without less harmful to the environment. So that is the thing. Just 1 minute. And solar dryer can be used to night purpose and to increase the so these solar systems work mainly during the daytime. If you want to make them work in the night time, we have to go for storage. The storage can be thermal storage. Now we are working extensively on thermal storage. This thermal storage can be even up to 16 hours storage year round. It can be year round. So therefore, dryer can work even night time with energy storage. There are thermal energy storage like phase change materials, then sensible energy storage materials, and so on. So therefore, it will work in the night time also. Solar energy equipments are very expensive, such as solar heaters for domestic use cannot be affordable for common man. Of course, you don't look at the electricity cost, so that is why you may think that is unaffordable. But if you look at electricity cost for hot water application, generally we advocate that using electricity for hot water the bathing purpose, it's a crime, because we cannot use high quality energy for a low quality application, because hot water application is a low quality application. So therefore, it's not unaffordable, definitely, because if you look at the overall cost which you spend on electricity for hot water application is much higher than what a solar hot water system. You can see that now it's gaining momentum. Mainly our building regulations are not that stringent, that is why it's not used. But it's not, as compared to the building cost, the solar hot water cost is nothing actually. It's definitely affordable, but I don't know on which context you are saying it's unaffordable. Then medium scale solar 1 megawatt to 5 megawatt power plants. Which technology is viable? Solar photovoltaics or solar thermal? Of course, see the difference between solar thermal and photovoltaics is one is a direct energy conversion, the other one is indirect energy conversion. For direct energy conversion, that's like photovoltaics, they are good for small scales and even modular structure. 1 to 5 megawatts, they are good as long as there is a good grid, but the efficiencies are very low. But if you go for solar thermal, the efficiencies are higher, and you can also use it in the night time with energy storage. But if you ask me this whether 1 to 5 megawatt, definitely photovoltaic is better for 1 to 5 megawatts. And the maintenance of the panels. Yes, of course, there's no much maintenance. Only maintenance is the cleaning. One in case of auto rickshaw, so it's only cleaning, and once in a week it needs to be cleaned. Or like our own vehicle, auto rickshaw vehicle, it has to be. If it is cleaned every day, it will be better. But otherwise, there is no other maintenance. Can we use yes, of course, we can use nanoparticles for desalination process. Especially whatever I mentioned here, most of them are thermal applications. So therefore, for thermal applications, the heat transfer plays a major role. When we use nanoparticles for improving the either heat transfer or evaporation condensation process, definitely it's a good idea to use nanoparticles. That's not a problem. Any other applications of energy regarding textile other than mechanical process of textiles? Of course, most of the textiles require process heat in the form of steam. So not only treating the effluents, but also this heat can be used for processing the textile, because they use boilers, either coal-based boilers or biomass-based boilers. Instead of those boilers, one can use solar energy. So therefore, solar energy not only used for treatment of effluents, but also used for the process of textiles. We can increase the efficiency of, how can we increase the efficiency of concentrating collectors? Efficiency can be, you know that concentrating collectors are optical thermal elements. First is optics. Solar radiation is converted into high concentration flux by optical element, either mirror or lens or glass, any one of those. So therefore, then after concentrating the flux, then subsequently transferring into the heat by a heat exchanger. That's absorption based. Again, it's optical and thermal component. So if you improve the efficiency of optics, like glass reflectivity, if you improve, or absorptivity will improve, then the overall concentrator efficiency can be improved. Solar thermal systems have, yes, of course, in India, dust problem is a major thing. In India, because a lot of particulate matter in the environment, so they deposit onto the panels. You must have seen even in our homes also, we can see dust accumulation. There's a substantial dust accumulation. because of the dusty conditions. So therefore, it's cleaning is an important thing. When we go for large scale plants, like large scale power plants, we go for robo cleaning. Manual cleaning is a bit difficult, but it has to be cleaned once in a week or once in a fortnight, because if you leave it for a longer period of time, the efficiency drops significantly. As I mentioned that this can be water treated and it can be eliminated, the dust can be eliminated by cleaning manually or robo cleaning. Now we are talking about drone cleaning. If the panels are inaccessible for long, then you can use drone, development of a drone with water and all, you can clean it, and wipers also there, you can clean the panels appropriately. How to improve storage portion of solar systems and any efficient technology. See, if you go for energy storage, there are several types of energy storages. One energy storage generally what we know is everybody is carrying energy storage is a battery, even your mobile phones here and there. So that energy storage, now lithium ion batteries and other things are coming up. But if you look at thermal energy storage, so in fact we are also working on flow batteries, mainly used for solar applications. But apart from that, thermal energy storage technologies are there. Those are generally fetch-in materials, because heat can be stored more efficient way than electricity, because the overall performance is much higher in case of thermal as compared to the battery storage, because again battery may pose problems for environment after their life, end of their life. So therefore it's there are very good technologies are there for energy storage in thermal as well as electricity. My research work is in solar air heater. How can we improve the efficiency and how storage for this system? So solar air heaters efficiency can be improved various methods, mainly increasing the surface area of the air heater, or circulating appropriate fuel, appropriate working fluid, or appropriate materials also, material efficient energy efficient materials, where it's a material, optical, thermal, and heat transfer aspects. If you try to address one or more of these, obviously you can improve the efficiency. And the air heating can also be done with a storage, that is a sensible energy storage, either packed bed or Febble bed, any bed, or fetch low temperature fetch-in materials can also be used for energy storage. Research development career future, the scope on solar energy and its application in India. Of course, there is a large potential of research. Research is there now. The main research on solar energy is improving the efficiency of the panels and energy storage, so that it can cater the round the clock, because our energy demand is not uniform throughout the day. We have more energy demand in daytime, less energy demand in nighttime. But even if you want to cater the nighttime demands, still we can use energy storage. Therefore, there is a good potential in India, and there's a lot of activities are going on. Even as I mentioned, that hydrogen energy can also be produced through the solar system. So therefore, there's a lot of potential in producing hydrogen from solar energy, as far as the research point of view. And energy storage, there is a lot of energy storage aspects can also be, there's a lot of potential for research applications. And of course, another main solar energy application is the process heat application. Most of the industries can be fitted with solar systems. That is another important application. So therefore, coming up with the process industries means pharmaceuticals, leather industries, textile industries, ceramic industries, and of course there are many other industries which can be fitted with solar energy. even dairy industry. We are giving a solution, agricultural industries like cold storages and dairy industry also. Solar tracking system, power system for power generation is worth. Of course, it's worth tracking system, because tracking system, what happens is when you implement tracking system, the cost of tracking should not be more than the energy which you recover by the tracking. So therefore, always the parasitic power should be minimal as compared to the power whatever power is generated, and the cost of tracking should not be very high. So therefore, if you maintain reliability, cost, and efficiency of the tracking system, it's a very good option for power generation. And good information. Install rooftop solar systems is IIT. Of course, we help in, because I have a good industrial association, and we are, as I mentioned, that for R4DC approach. So we have given transferred our technology to many companies. I think as many as I think maybe 12 to 15 companies, and I have incubated about 9 companies because these are, most of them are startups, and now they are doing very well in solar. And can you suggest any topic which we can choose for our PhD purpose? You see that whatever I presented here, all of them can be taken, because there is a lot of potential for future research in these areas. Some of these, because I have not given a lot of technical information, because one is it's a highly heterogeneous group, and secondly, some unpublished work also I have not given. Some I have given, but some I have not given. So therefore, what you can see, we have developed some 20 technologies. In these 20 technologies, you can carry out your research in any one of those further. Because all these are, why I have put that, because I know that most of the participants are either young researchers or to start researchers. So therefore, I have given these. Therefore, you can even look at these aspects. That's why my intention of showing 20 technology was that. And is there any solar organic Rankine cycle installed in India? There are few, because solar organic Rankine cycle efficiency is rather low. In fact, the first one was installed in IIT Madras way back in 1970s, but it was low efficient. But there are 1 or 2 plants in India based on organic Rankine cycle. But organic Rankine cycle mainly used for low heat or waste heat applications. How to calculate battery volt amperes according to the solar panel watts? So this is I don't know what exactly you are asking, but this is more technical. You again, it's both are power systems based on the we are talking about MPPT, maximum power point tracker. Based on the maximum power point tracker, it gives output panel, and then accordingly it's stored in battery. So the battery voltage either 12 volts, 24 and 48 volts, depending upon the load conditions. So it's more technical. We have to go deeply into that. I don't know if you can offline. You can contact me. I will tell you how to do that. Flat plate collector is suitable for power generation. You know that most of your mechanical engineers, you must have studied heat engine. Heat engine is a cycle which goes under cyclic process, and interaction at the boundaries, heat and work. So you know that the heat engine efficiency depends on the 2 important source and sinks. The source has to be at higher temperature, sink has to be at lower temperature. So therefore, the efficiency of a system dependent on the source temperature. If you use flat plate collector, the source temperature is low. So therefore, theoretically, we can produce power from flat plate, but the efficiency is, technically it's possible, but economically it's not possible. It's not suitable for power generation economically, because the efficiencies are very, very low. You can give contact details, companies who associated with IIT. So it's most of them are in my website, web page. You can look at them. You can see my web page. Thank you. Okay. I think questions are over. All of them I could answer. Thank you for your questions. This one. I think it's fine. Yeah.
Thank you, sir. Thank you for your valuable and informative session. Just now we were listening to Dr. K Srinivas Reddy, Professor, Department of Mechanical Engineering, IIT Madras, on the topic Solar Thermal Energy Utilization, Uses and Applications. It was indeed our pleasure to listen from this eminent person for the last 1.5 hours. We have gained a lot of information acquired by him through his real life experience. I hope all the participants were very much benefited from this session. I once again thank you, sir, for sparing your valuable time with us, and we hope to see you again in future events. Thank you, sir.
Thank you very much. I also wish you all the best for the rest of these sessions or the rest of the program. Thank you very much. So now I am signing off. Thank you.
Thank you, sir.